Now, welcome back to the next session, sir. We are in the process of doing practical problems related to capacity planning. Okay. Look at the question number 13, which is given in your CMA material. Question number 13. Question number 13. A manager has to decide about the number of machines to be purchased. He has three options: purchasing 1 or 2 or 3 machines. The data are given below. Number of machines, annual fixed cost in rupees, range of output. Number of machines 1, 2, 3. Fixed cost is given 12,000 rupees, 15,000 rupees and 21,000 rupees. 0 to 300, 300 to 600, 600 to 900. Variable cost is given as rupees 30, rupees 20 per unit. Selling price is given as rupees 50 per unit. This is the information given, sir. What is your first question? Calculate the break-even point for each range. What does it mean actually? When the manager decided to purchase one machine, what is the break-even point for this? When he decided to purchase 2 machines, then calculate the break-even point. Similarly, when he decided to purchase 3 machines, calculate the break-even point. Next, what is your second question? If the projected demand is between 600 units and 650 units, how many machines should the manager purchase? This is the problem given. Now, solution, look at this, sir. Calculate contribution per unit. That is S minus V. Rupees 50 minus 20 is equal to rupees 30. Contribution per unit is equal to rupees 30. Break-even point is equal to, in units, is equal to fixed cost divided by contribution per unit. For one machine, this is rupees 12,000 divided by rupees 30 per unit. Rupees cancel, 0 cancel, 400 units. For 2 machines, this is rupees 15,000 divided by rupees 30 per unit is equal to 500 units. For 3 machines, this is rupees 21,000 divided by rupees 30 per unit. Rupees cancel. This is 700 units. So, first question, calculate the break-even point for these 3 options. When the manager is decided to purchase one machine only, break-even point is 400 units, sir. break-even point is more than the maximum capacity of the machine. How many units demand we can satisfy? 300 units demand only we can satisfy. But for how many units we are getting break-even point? For 400 units we are getting break-even point. So how can I take the decision? First, since maximum capacity for one machine is less than its break-even point, maximum capacity for one machine is less than its break-even point. So, purchasing one machine is ruled out. We are not at all interested to purchase one machine because maximum capacity of this machine is 300 units, which is 100 units less than the break-even point. For 2 and 3 machines, break-even point is less than maximum capacity. For 2 and 3 machines, break-even point is less than maximum capacity. So we may consider purchasing 2 machines or 3. Now sir, 2 machines I have to purchase or 3 machines I have to purchase, again is dependent on the market demand. Okay, given in the question, demand is varying from 600 units to 650 units. Since demand is from 600 units to 650 units. Okay. First you consider the upper limit for the demand. Upper limit for the demand is 650 units. And break-even point for 3 machines is 700 units. Upper limit for demand is less than break-even point for 3 machines. So, purchasing 3 machines is also not advisable. Is not advisable. Okay. So purchasing 3 machines option also ruled out. We have only one option left over, purchasing of 2 machines. When I purchase 2 machines, how many units maximum I can satisfy? 600 units demand only I can satisfy. So what is the final decision we have to take? Accept the demand up to 600 units. Accept the demand up to 600 units and reject the further demand. Therefore, final conclusion. Purchase 2 machines and accept the demand up to 600 units and reject the further demand. This is the decision we have to take. Purchase 2 machines and accept the demand up to 600 units and reject the further demand. This is the decision the manager has to take. Okay. Look at the solution one more time, sir. What is given? A manager has to decide how many machines he has to purchase. 3 alternatives available or 3 options available. Option 1, purchase 1 machine. Fixed cost for this is 12,000 rupees. Variable cost is 20 rupees per unit. And how many units demand we can satisfy? A maximum of 300 units. Option 2, purchase 2 machines. Then fixed cost is 15,000 rupees. Maximum demand we can satisfy is up to 600 units. Option 3, purchase 3 machines. Then fixed cost is 21,000. Maximum demand up to 900 units we can satisfy. Now sir, with this information, what is asking? Calculate the break-even point. Calculate the break-even point for each machine. How can we calculate the break-even point? Break-even point in units is equal to fixed cost divided by contribution per unit. So for one machine, fixed cost is 12,000. Contribution per unit is 30 rupees per unit. Selling price is also given. S minus V is equal to contribution. So 400 units is the break-even point for one machine. Similarly, 500 units is the break-even point for two machines. 700 units is the break-even point for three machines. Okay. Now, after calculation of break-even point is over, we have to decide for how many machines we have to purchase. Look at the decisions, sir, how I am analyzing. Break-even point for one machine is 400 units. Break-even point for one machine is 400 units. And this is less than the maximum capacity, this is more than the maximum capacity of one machine, which is 300 units. Look at this point one more time. For one machine, break-even point is 400 units and maximum capacity with one machine is 300 units. Demand we can satisfy. Therefore, purchasing of one machine is ruled out. Why I am ruling out this decision? Because break-even point is greater than the maximum capacity. Go to the second one, that is two machines option and three machines option. With two machines and three machines, break-even points are less than the maximum capacity of the respective machines. Okay. So, you have two options. You can go for two machines or you can go for three machines. How many machines I have to purchase? Again, is dependent on my market demand. What is the market demand, sir? It is varying from 600 units to 650 units given in the problem. Demand is varying from 600 units to 650. If I consider the upper limit of the demand, 650 units. 650 is less than 700, which is the break-even point for three machines. Clear? Therefore, purchasing of three machines is also not advisable here. Only one option left over for us, purchasing of two machines. With this option, purchasing of two machines, sir, how much demand I can accept? What is the maximum demand we can satisfy with two machines? Only 600 units. Only 600 units demand I can accept or I can satisfy with two machines. So finally, what decision I am taking? Purchase two machines and accept the demand of 600 units. Accept the demand of 600 units. Accept the demand of 600 units and reject the further demand. This is the final conclusion you have to take. Clear, sir? Very good. Note down the solution. I'll give you 1 minute time. Now, look at the question number 12. Question number 12. An item is produced in a plant having a fixed cost of rupees 6,000 per month. This is question number 12. Fixed cost is given rupees 6,000. 6,000. Variable cost is rupees 2 per unit. Variable cost is rupees 2 per unit. Selling price is given as rupees 7 per unit. Selling price is given as rupees 7 per unit. Calculate break-even volume. Second question, if 1,000 units are produced and sold in a month, what will be the profit? Next, how many units should be produced to earn a profit of rupees 4,000 per month? These are the three questions we are having. Now, sir, solution. Calculate total revenue. This is price multiplied with number of units we are selling at this price. Price multiplied with number of units we are selling. How many units we are selling? X number of units we are selling, which we have to calculate. So this is equal to 7x. Total cost is equal to variable cost plus fixed cost. This is 2x plus 6,000. Total cost is equal to 2x plus 6,000. Now, sir, first question. At a break-even point, total revenue is equal to total cost. Total revenue is equal to total cost. So, 7x is equal to 6,000 plus 2x. Keep variables on one side. 7x minus 2x is equal to 6,000. 5x is equal to 6,000. X is equal to 6,000 divided by 5. 1200 units. 1200 units. So at 1200 units we are getting break-even point. When X is greater than 1200, profit zone. When X is less than 1200 units, loss zone. Okay, sir. So first part of the question is over. Look at the second part of the question. If 1,000 units are produced, and sold in a month, what would be the profit? So let us calculate profit in terms of output. Profit is equal to total revenue minus total cost. Profit is equal to total revenue minus total cost. 7x minus 2x plus 6,000. 7x minus 2x minus 6,000. 5x minus 6,000 is equal to profit. Okay, sir. Given X is equal to 1,000, P of X profit is equal to question mark. X is equal to 1,000, profit is equal to question mark. So profit at X is equal to 1,000. 5 into 1,000 minus 6,000. 5,000 minus 6,000. This is 1,000 loss. It is 1,000 loss. It is 1,000 loss. Look at the third part of the question. Look at the third part of the question. How many units should be produced to earn a profit of rupees 4,000 per month? Given TP is equal to rupees 4,000, X is equal to question mark. At what sales volume you can expect a profit of rupees 4,000. So again consider total profit is equal to TR minus TC. This is already we calculated for the second problem. 5x minus 6,000. 5x minus 6,000. So total profit is given as 4,000 rupees is equal to 5x minus 6,000. 5x minus 6,000. So minus 6,000 taken to this side. 5x. 10,000 is equal to 5x. X is equal to 10,000 divided by 5. 2,000 units. So at a sales volume of 2,000 units, the firm can expect a profit of rupees 4,000. Profit of rupees 4,000. Okay, sir. This is the answer to the given question. Note down the solution, sir. Look at the question number 14, sir. Of our CMA material, a firm has 4 work centers A, B, C and D in series with individual capacities in units per day is given below. So here our work centers will also form part of our decision. What is given, sir? Raw material is given as input. Work center A, work center B, work center C, work center D, and actual output. Actual output. Work center A can handle 450 units, B can handle 360 units, C can handle 340 units, D can handle 400 units. Actual output is equal to 300. Okay. These numbers given here 450, 360, 340, 400 will represent what? Respective capacities of these work centers to handle. It can handle 450 units. It is 360, C 340 only, D 400. So your decision is based on the capacity of your work centers. Look at this one. Identify the bottleneck center. Bottleneck center. What is meant by bottleneck center? Out of the 4 work centers we have, sir, here, A, B, C, D. C is having least capacity 340 units. Work center C can handle 340 units only. That is called bottleneck center. So bottleneck center is the work center having the minimum capacity. So it is the work center. It is the work center with minimum capacity. Therefore, work center C is the bottleneck center. Is the bottleneck center. Work center C is the bottleneck center. What is your second question, sir? What is the system capacity? System capacity is the capacity of bottleneck center. System capacity is the capacity of bottleneck center. That is, system capacity is equal to 340 units. 340 units. Next, what is the system efficiency? System efficiency is equal to actual output divided by system capacity into 100. Actual output is equal to 300 by 340 into 100. 300 divided by 340 into 100 is equal to 88.235% capacity. So the system is not at 100% efficiency. 88.235. That is the system efficiency. Okay, sir. When you are answering this question, you will get doubts regarding what is meant by system efficiency, what is meant by utilization. Okay. For these type of problems, that is for these type of doubts, we have some problems. I am going to those also. Before that, you take up the solution for this. Okay, sir. Look at the example number 1. That is question number 1. Question number 1. A worker works for 8 hours in each shift. A worker works for 8 hours in each shift, but during that time he had clocked for 7 hours on the job. Calculate his utilization. Calculate utilization. Okay, sir. How many hours he has to work? 8 hours. He has to pay attention on the duty. Worker works for 8 hours in each shift, but during that time he had clocked for 7 hours. What does it mean actually? He was busy with the work only for 7 hours. It means remaining 1 hour he had not paid any attention on the job. It means he may be talking to other colleagues, or he may be inside the canteen, or maybe some other reasons you can take up. So how can I calculate utilization? Utilization is equal to hours worked divided by hours available. This ratio when multiplied with 100, you will get utilization percentage wise. He worked 7 hours only. Hours available is equal to 8 hours, sir, into 100. This is equal to 87.5 hours, 5%. So out of 8 hours, 7 hours only he had clocked for the work. It means 87.5% utilization of his presence inside the factory. So remaining time is not utilized towards the work. As a consequence of this, what will be the effect on the firm? Look at this, sir. For example, company is manufacturing some products. Standard time allowed is equal to 30 minutes to produce each item. 30 minutes per unit. 30 minutes per unit. It means 2 units per hour. Standard time allowed means output is equal to 2 units per hour in 8 hours shift. In 8 hours shift, 2 units, 2 into 8, 16 units per day. 16 hours per day he has to produce. So, in a month, 16 units per day into, let us take 24 days in a month. 24 days in a month. So this is equal to 16 into 24, 384 units. 384 units per month the worker has to produce according to the standards. Let us calculate actual output. Actual output, sir. So he is working 7 hours only. 7 hours only. So 2 units per hour into 7 hours in a day into 24. So this is 2 into 7 into 24. 336. So loss is equal to, in terms of output, 384 minus 336, 48 units loss. Production loss. Okay, sir. In 1 hour, he has to produce 2 units. That is not producing because he clocked only for 7 hours. So 48 units loss per month into 12. 576 units on 1 worker. Suppose if the organization is having some 100 workers. So 576 into 100. 57,600 units loss, because actual production is less than the standard. The worker has not reported 8 hours time for the duty. Even though he is inside the factory, he clocked only for 7 hours. So the management has to take control on this one. So utilization, this way it is calculated with the help of this utilization. This is the MIS, Managerial Information System. Managers will get additional information. Okay, sir. Take up the solution for this one also. Okay. Now look at the question number 2. Standard time for a task is 8 hours. Question number 2. Standard time allowed is equal to 8 hours. Calculate the efficiency of the work person in the following cases. Worker completes the job in 10 hours. First one. Worker completes the job in 10 hours. So efficiency is equal to actual time divided by standard time into 100. 10 divided by 8. No, sorry. This is standard hours divided by efficiency. Sorry. Standard hours divided by actual hours into 100. Standard hours 8, actual hours 10 into 100. 80%. Efficiency is of the worker is 80%. He has not given 100%. 80% is the efficiency. Why? He has taken 2 additional hours extra to complete the work. Look at the question, sir. How many hours are fixed in the organization to produce the work? A unit, 8 hours is the standard time allowed to perform the work. How many hours are taken by the worker? 10 hours are taken. Means 2 extra hours are taken by this worker. Why? Because he is working at 80% efficiency. Look at the second part of the question. Worker completes the job in 6 hours. Worker completes the job in 6 hours. Therefore, efficiency is equal to standard hours 8, actual hours 6 into 100. So this is equal to 800 divided by 6, 133.33%. This worker has given in the second case more than 100%. So this way, based on the efficiency, bonus is given because here labor productivity is more. Labor productivity is more than 100%. Here labor productivity is less than 100%. Productivity is the index of performance, how the organization is doing well. This is evaluated with the help of productivity. Labor productivity is one tool we are having. So in the first case, labor productivity is less, 80%. At 80% efficiency, the worker is worked here. Therefore, it is less than the standard, 100% he has not given. Go to the second one. Since he completed the work in 6 hours only, it means the worker has given more than 100%. Okay. Take up the solution for this. Look at the question number 3, sir. A workshop operates in 2 shifts of 8 hours per day, and it has 10 machines. It works for 5 days in a week. Machine utilization is 90%. Efficiency of the machine is 85%. Calculate the designed or rated capacity of the workshop in terms of standard hours. Okay, read the question one more time. How many shifts it is working? 2 shifts. So designed capacity is equal to number of machines into number of shifts into number of hours per shift into utilization into efficiency. Utilization into efficiency. Number of machines, how many? 10 machines. Number of shifts, 2. 8 hours per day. Utilization is equal to, utilization is given how much? 90%. 0.90. 0.90 into efficiency. Efficiency is given as 85%. Efficiency 85%. Multiply this, you will get 10 into 2 into 8 into 0.90 into 0.85. 122.4. Number of days is not taken. Into number of days. Into number of days. Into 5. How many days? 5 days in a week. So this is into 5. 612 standard hours. This is the answer to calculate the designed capacity. Okay, sir. Note down the solution. Okay, sir. With this, your capacity planning concept is over, sir. More or less every time, you will get one question of 3 marks from this one. From theory point of view, which areas you have to concentrate based on the definition. How many types of capacity can be classified in how many ways? That is the first question. How to calculate the designed capacity. Second one, what points you have to consider for increasing the capacity. These are the 3 areas where you have to concentrate, and these are the problematic part. So, thank you.